In this video, we're going to look at inverses of square matrix. And in this first example, we're going to take a look at taking an inverse of a 2 by 2 matrix. So we have a shortcut for a 2 by 2. So if we have A matrix is equal to A, B, C, D, then A inverse, and we notate A inverse by A superscript -1, is equal to 1 over A times D minus B times C times, now if you notice we flip the diagonal, so A and D flip spots, and then the back diagonal numbers, B and C, they get negative numbers. So let's take a look at an example. Here we have A is equal to 4, 7, 2, 1, and we want to find A inverse. So A inverse, or A -1, is equal to 1 over A times D, so 4 times 1, minus 2 times 7, and now times, we're going to flip 4 and 1, so now we have 1 in this corner and 4 in the lower corner, and we're going to add negatives to B and C. So we have -7 and -2. And now we have 1 over 4 minus 14, or -1/10, times 1, -2, -7, and 4. And now we're going to multiply everything in the matrix by -1/10. We have a constant multiple. So we end up with -1/10, 7/10, 1/5, and -2/5. And this is our inverse of our original matrix. Now in the next example, we have A is equal to 3, 1, 2, 1, 2, 3, 1, 1, 1, and we want to find an inverse. Now, there's no shortcut for a 3 by 3 or bigger. So the way we're going to do this now is we're going to set up our A matrix, and then we're going to use the identity matrix as well. So A inverse is equal to 3, 1, 2, 1, 2, 3, 1, 1, 1, and then we're going to put the identity matrix on the right side of our line. And now we're going to perform row operations to create the identity matrix on the left, and whatever turns out on the right becomes our inverse matrix. So we have, first thing we need to do is get a 1 in our upper left corner. So I'm going to flip row 1 and row 2. So we have 1, 2, 3, 0, 1, 0, 3, 1, 2, 1, 0, 0, and then row 3 stayed the same. So now that we have a 1, this becomes our pivot row, and now we need to get zeros where our 3 and our 1 is, so we're going to do -3 times row 1 plus row 2, and we're going to put that in row 2, and then we're going to do -1 times row 1 plus row 3 to row 3. And when we do that, we get row 1 not changing, okay, and now we do -3 times 1 is -3, plus 3 is 0. -3 times 2 is -6, plus 1 is -5. -3 times 3 is -9, plus 2 is -7. -3 times 0 is 0, plus 1. -3 times 1 is -3 plus 0, gives us -3. and negative 3 times 0 plus 0 is 0. And now we have row 3 minus row 1. So 1 minus 1 is 0. 1 minus 2 is negative 1. 1 minus 3 is negative 2. 0 minus 0 gives us 0. 0 minus 1 gives us negative 1. And 1 minus 0 is 1. Now we need to get our negative 5 to be a 1. So we're going to do negative 1/5 times row 2, and we're going to put it in row 2. So row 1 and 3 aren't changing. And now our row 2, we have 0, 1, we have 7/5, negative 1/5, 3/5, and 0. And now our next move is to get a 0 where this negative 1 is. So we're going to do row 2 plus row 3, and we're going to put it in row 3. And that's our pivot row. So row 1's not changing. Row 2's not changing. And now row 2 plus row 3, and we're going to put it in row 3. So 0 plus 0, 1 minus 1, and now we have 7/5 minus 2. So we have 7/5 minus, and we can write 2 as 10 over 5, so we have negative 3/5. Negative 1/5 plus 0 is negative 1/5. We have 3/5 minus 1, or 5/5, gives us negative 2/5. And we have 0 plus 1 gives us 1. And now we want to get a 1 where we have negative 3/5 for our final diagonal 1. So here we're going to multiply row 3 by negative 5/3 times row 3, and we're going to put it in row 3. So we have rows 1 and 2 are not changing. And now row 3, we have 2 zeros, so both of those when multiplied would still be 0. Negative 5/3 times negative 3/5 gives me 1. And now we have negative 1/5 times negative 5/3. The negatives are going to cancel to give me a positive, and the 5s are going to cancel. So I'm left with 1/3. Negative 2/5 times negative 5/3. Again, the 5s are going to cancel, and the negatives are going to make a positive. So I have 2/3. And negative 5/3. Now we're going to use the one we just found as our pivot row and get zeros where our 7/5 are and our 3. So we have negative 7/5 times row 3 plus row 2, and we're going to put it in row 2. And then we have negative 3 times row 3 plus row 1, and we're going to put that in row 1. So for the first row, we have negative 3 times row 3, so we have zeros in the first two spots, so the 1 and the 2 are going to carry. And now we have negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1/3 is negative 1 plus 0 is negative 1. Negative 3 times 2/3 is negative 2. Plus 1 is negative 1. And negative 3 times negative 5/3 gives me 5 plus 0. In row 2, we have a 0 times negative 7/5 plus 0 gives me 0. Negative 7/5 times 0 again is 0 plus 1 is 1. Negative 7/5 times 1 is negative 7/5 plus 7/5 gives me 0. And now I have negative 7/5 times 1/3 is equal to negative 7 over 15 plus negative 1 over 5, which I can rewrite as minus 3 over 15. So I get negative 10/15. Or I can write that as negative 2/3. I have 2/3 times negative 7/5, which gives me negative 14/15. And we want to add 3/5, so we can write that as plus 9 over 15. So I get negative 5 over 15, or negative 1/3. And now I have negative 7/5 times negative 5/3. Our 5's are going to cancel, and our negatives are going to turn into positives, and that leaves me with 7/3. And then we're adding 0, so I'm just left with 7/3. And then row 3 stayed the same. And now we need to get a 0 where our 2 is. So we're going to use row 2 as our pivot row, and we're going to do negative 2 times row 2 plus row 1, and we're going to put it in row 1. So we have negative 2 times 0 is 0 plus 1, 1. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 0 plus 0 is 0. Negative 2 times negative 2/3 is positive 4/3. Minus 1 gives us 1/3. Negative 2 times negative 1/3 is positive 2/3. Minus 1 gives me negative 1/3. And negative 2 times 7/3 is negative 14/3. And then we have plus 5, which we could write as plus 15 over 3, which leaves me with positive 1/3. And now row 2 and 3 stay the same. So now you can see we created the identity matrix on the left. So now our A inverse is equal to 1/3, negative 1/3, 1/3, negative 2/3, negative 1/3, 7/3, and 1/3, 2/3, negative 5/3. And that's our video on inverses of square matrix.